Today we're going to talk about what happens when we're dividing numbers that have the same base. Yesterday we talked about products, and today we're going to talk about quotients. So for example, if I have a to the fifth divided by a to the third, all you have to do is subtract those exponents, 5 minus 3, to get a to the second power. Okay, so down here, first of all, it should say divide. Okay, so let's look at it. Y to the, sorry, apparently my Siri is going to help us out. Okay, so y to the 20th over y to the 17th, 20 minus 17 is y to the third. X to the 13th over x to the 8th, 13 minus 8 is x to the 5th. M to the 5th over m to the 4th, right, divided by, is just m, or m to the first power. X to the 6th over x, 6 minus 1 would be x to the 5th power. So now let's look a little bit down here. Okay, so y to the 10th over y to the 17th, 10 minus 17 is negative 7. 3 minus 6, x to the negative third. 9 minus 14 would be g to the negative 5th power. 15 minus 17 would be c to the power of negative 2. So then down here it says a negative exponent indicates that there's more of a factor in the denominator, right? If we looked at this, this is a negative because 10 minus 17, if I were to write it out, I would have y times y times y 10 times on the top, but 17 times in the denominator. So it means that there's more of my factor in the denominator. And so we always want to write our answers with positive exponents. So if I have a negative exponent, that's telling me that it means that there are actually more of that factor in the denominator. So whenever we have a negative exponent, we actually want to put it in the denominator of our fraction by putting it underneath a 1. So 3 to the negative first is 1 over 3 to the first. 5 to the negative 10th is 1 over 5 to the 10th. X to the negative 6th is 1 over x to the positive 6. Okay, so let's look up here at these last 4 examples that we did right here. Okay, on a homework assignment, I would count these incorrect because we never want to write with a negative exponent. So let's look at it, right? Y to the negative 7th, think about what this means. It means that there's more y's in the denominator. That's why it's 1 over y to the 7th. Were there more x's in the numerator or the denominator? There were more in the denominator. 3 more. So 1 over x to the third. So do these last 2 right here, and then unpause it and come back and we'll check your answer. Okay, so this should be written as 1 over g to the 5th and 1 over c squared. Okay, we always, always, always want to make sure that we're writing with positive exponents. Okay, so down here it says let's look at x to the 100th power over x to the 100th power. So what's 100? 100 minus 100? 0. Okay, but what do we know about this? If anything is the same in the numerator and the denominator, x to the 100th power goes into x to the 100th power 1 time. Right? If I said 7 over 7, oh, well, that's 1, right? 51 over 51, oh, that's 1. X to the 100th over x to the 100th is 1. So what we can conclude is that anything to the 0 power is going to be the number 1, okay? Because what that's telling you is that the exponents were the exact same, so it's the same value in the numerator and the denominator. So 7 to the 0 power, 1. X to the 0 power, 1. X to the third over x to the third, 1.